Hello everyone, today I'm back with another video and I'm going to be talking about cycloalkanes. I just wanted to say I know some of you guys are saving the videos, but please also follow me here and on YouTube so I know that you guys are really enjoying the content. I wanted to give you like the main examples in this video, so let's begin. So please don't cheat because I know that you guys can see like the names, so don't cheat. I want you guys to actually learn why and how you're going to name these things. So that way, when you're on the exam, obviously they're not going to give you the answer. So I really want you guys to learn the process of doing it. So let's begin with, I'm assuming that you've already watched the other video that I made on alkanes, on linear alkanes. And so if you haven't done so, please watch that so that way you'll understand and how I'm building off it. So I told you guys in the alkanes video about like the name, like this part that I put in purple is the crux of it, like what it is. And then ane was the suffix and it's going to give you what it's composed of, and the methyl are all the substituents that go on top of that main chain. So that's the blue portion. It tells you the substituents. So in this case, it doesn't matter which way you go. It doesn't matter, in other words, if you do 1, 2, 3, 4, 5, 6, or if you do 1, 2, 3, 4, 5, 6. Again, why does it not matter? Because in this case, you only have one substituent. So, and that's the other reason why I'm not putting 1-methyl cyclohexane, because again, you only have one substituent. So it's obvious that it's going to be number 1 because you, again, only have one substituent. So in this case, you have a cyclohexane. You counted the rings. You know it's a cyclo because it's a ring, and you know it's hexane because there's 6 carbons on this parent chain. Like again, 1, 2, 3, 4, 5, 6. And you have a methyl group. So there you go. That's why I named it this way. Now let's go to a more complicated one. Not that complicated, but okay. So before we even get into everything, you already know that the ring is a cyclohexane. 1, 2, 3, 4, 5, 6. Or you could actually do, I'm going to do in yellow, 1, 2, 3, 4, 5, 6. So in this case, it doesn't matter which one you're doing, if you're doing the pink or if you're doing the orange, because again, these two substituents are both CH3s. They're both methyl groups. So if you didn't see and you're colorblind, you can do 1, 2, 3, or you can do 1, 2, 3. And it's the same because, again, these are both methyl groups. But what is important for you to realize is that here, both of your methyl groups have stereochemistry, and both of them are in the same orientation. They're both bold. So if they are both bold or both dash, that is going to be cis. If one is bold and one is dash, it's going to be trans. Again, I have a video on cis and trans, so if you haven't watched it, please go back and watch that. So in this case, you have cis. So you're going to write that first. You have 2 methyl groups. Again, it doesn't matter which one is 1 or which one is 3. Again, it's the same because, again, like I showed you, these 2 substituents are the same. So, but you do end up having a 1 and you do end up having a 3. So it's going to be 1, 3, and then you have 2 methyls. So it's dimethyl, okay? And cyclohexane. Because again, we know that this is a cyclo because it's a ring, hex because there's 6 carbons, and ane because it's an alkene. Now this is trans. This is what we talked about, right? So, but it's not a cyclohexane. How many carbons is it? So that's what we're going to do. We're going to count. So 1, 2, 3, 4, 5. Again, this can be 1, 2, or 1, 2. it doesn't matter because both of these groups are the same. Don't worry, we're going to get practice of groups that are not the same. But for right now, I just want you to feel comfortable with naming. You're not going to put one here or one here or one here randomly. That's not going to happen. You need to give the substituents the lowest possible number. And if, like in this case, you have 2, you're going to go in that direction, in that order. Notice that I put 1 here and I didn't put 2 here. I went to the next substituent to give the next substituent the lowest possible number. Okay, again, orientation, right? So this is in trans orientation. If you see, you have 1 bold group and 1 dash group. So it's going to be trans. Again, it's 1, 2. It doesn't matter which one is 1 and which one is 2 because they're the same group. They're both methyl, so it's dimethyl, and then cyclopentane because you have, it's a 5-carbon ring. Okay, let's go to the next one. Pay attention to this one. It's really important, and I'm not exaggerating. So here, this one is not either 1, 2 or 1, 2. This one is set. It's specific. And you're going to say, why? Well, the other ones, it didn't matter because they were the same group. But this one matters because it's a different group. And this one, notice that you have an isopropyl. And this one, you have a methyl. Isopropyl has priority over methyl. If you want to know how do you know which one has priority in general, there's a sheet for that specifically that tells you which group has priority over the other one. In this case, I'm telling you isopropyl has priority. So isopropyl will be number 1 and methyl will be number 2. And then for naming, I'm not naming in accordance with 1, 2, and numerically is what I'm trying to say. I'm naming because this one begins with I and this one begins with M. And you'll see that in the next one that we do. Again, it's cyclobutane. Bute is for 4. 1, 2, 3, 4. So it's 1 isopropyl, 2 methyl cyclobutane. Now let's go here to the next one. This is an example to show you what I was trying to say before. So again, pay attention because this is a very good example of how they try to trip you up. So a lot of students will say, oh, bromine has priority. It's 133. Heck no, it's not 133. Why? Why is that? I made this mistake, so I know it. I remember yesterday. Why did I make this mistake? Because you want to give not only the lowest number to the substituents. So if I do 1, 1, 2 substituents get like the lower number, right? Because you want them to have the lowest number possible. You want, and so it's going to be 1, 1. So it's 1, 1, and this is 3. So again, the substituents need to get the lowest number possible. And if you did 1, 2, 3, 3, then 2 numbers are getting 3 when 2 numbers could actually get 1. And so 1 is better. 1 is the lowest number possible. So we're going to go with 1, 1. Now, when you are doing the actual name, bromine is going to come first. And so bromine, because it begins with a B, like I told you before, it's going to be 3 bromo, 1, 1. And yes, you cannot just put 1 dimethyl. No, you have to write 1, 1. And dimethyl, because you have 2 methyl groups, cyclohexane. Again, you want to give the lowest possible number to the substituents. And in this case, you're giving 2 substituents an even lower number. So that's why you begin 1, 1 with the dimethyls and not the bromine. If the bromine had, for example, a methyl on there, yeah, sure. But in this case, you have 2 methyl groups and only 1 bromine. So the new for the numbering on this one, just to recap, this is 1, this is 2, this is 3, 4, 5, and 6. And then here's another example. Again, this one is going to have priority, and it's not because it begins with a B. It's really because bromine has priority over methyl. And in naming, it just so happens to be that bromine begins with a B and methyl begins with an M. So it's trans 1-bromo-2-methyl cyclohexane. Again, you're putting trans because you're putting the orientation that it's in. Next one is really simple. You have 1,4-dimethyl cyclohexane. And what I want to say about this one is that when you go into OChem 2, you talk about like OM and P. This is para orientation. I'll make another separate video on that, so you don't necessarily have to use this name that I did. But again, that's going to be in another video. But for simplicity's sake, yes, you can just put 1,4-dimethyl cyclohexane. And again, all of these, well, not all of these examples, but some molecules per se, like they have different ways that you can name them just depending on it. It's not like all of them only have one name. Sometimes they have 3 different names or 2 different names, just depending on how you are naming these things. Okay, and lastly is an easy one. Just to recap, if you have 2 of the same, it's di. If you have 3 of the same, it's tri. So you're going to have, again, it doesn't matter if you do 1, 2, 3 or 1, 2, 3 because they're all the same. So it's going to be 1, 2, 3 trimethyl cyclohexane. If you enjoyed this video, please follow and share, and follow me here and on YouTube, and like, and thank you for watching.